I gotta ask you something, MG. Sure. So I have already trained a machine learning model for batch prediction, and I'm thinking of using it like once in a week. And because of each time that I'm doing prediction for batch scenario, my input size of data might be slightly different. So could you please do me a favor, and whenever I want to do a prediction, you can just choose the right compute size for me and trigger my scoring code, please? If you don't mind, actually. Oh, definitely. No, I'm not going to do this. Wait. I said I'm not going to do this because Azure ML batch endpoint does this. I mean, with Azure ML batch endpoint, you can have your batch prediction over multiple computes of a cluster in parallel, and even you can schedule your batch prediction based on the time or trigger it through an API call. Then shall we check it out? No? Okay, then see you next week, everyone. Okay, I call it back. Let's go! Hello everyone and welcome back. This is MG and here I am with another video which I'm going to talk about Azure Machine Learning Batch Endpoint, that you can leverage this great capability for your batch prediction scenarios, that you can have a parallelized solution having multiple computes of a cluster that does the batch prediction for you in parallel, and you can have this solution scheduled based on the time or even can be triggered through an API call. So you focus on your machine learning more rather than focusing on the infrastructure. This one's gonna be very impactful solution, so let's check it out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Perfect, let's just start with, first of all, what is batch endpoint? So technically, when you have a machine learning project, and you have already trained a model and now you're in a stage that you want to deploy the model, or in an inferencing phase that you're planning of how you would like to score the model and come up with those predictions to provide service for the end user, right? So technically you might go with a real-time solution. For instance, you want to have a server running 24/7 that it actually run your model. So whenever you want to do a prediction, that server is listening, you can call your model which is deployed over that server and you get the predictions back. Let's say you have some streaming data coming in and at the same time you want to do predictions on the top of that. So every second, even less than a second, you are doing the predictions. So for those scenarios, we go with real-time endpoints. I created a separate video that we talked about rollout deployment, green-blue deployment, that we deal with a little bit of real-time manage endpoints of Azure ML. I'll try to add the link of that video on the top right side of this video screen. But here we are talking about the batch endpoint scenario, which means I do not have the real-time requirements. Let's say I want to do predictions once a day, once a week, once a month, or based on a specific schedule, and my input data for that model is batch load of data. For example, you do have a object detection model for detecting specific objects from the given image, and every week you have new images, let's say 100 images coming in. So when that 100 new images are ready, you want to trigger your model. All those 100 images will go through your model and you will have, for example, 100 predicted objects out of those images. That you want to have a model, it will run on the time that you want, not 24/7, because that's going to be a waste of server. And you want to make it scalable, because maybe this week you have 100 images for the input data, but for the next week that you want to wake up your model to do the prediction, you might have thousands of images. So the data might be varying in aspect of size. So you want to make sure that the compute size that you're choosing for this batch prediction can be scaled automatically to be responsible and respond to any input size of data. So you will be not concerned about how my model gonna perform if the data gonna be bigger next week. This is exactly the benefit and the description of managed batch endpoint in Azure ML that we're gonna talk about. As you can see here, as a client, let's say I want to call this batch endpoint that I have deployed in Azure ML. This is exactly what we're gonna do. This batch endpoint will call your model that you have registered and deployed before with the specified compute, and that compute will be a cluster. Let's say from minimum 1 nodes to maximum 5 nodes, or minimum 0 to maximum 10. That means whenever your input data is bigger, so that compute cluster will be scaled automatically to more nodes to crunch your input data to multiple batch sizes, and each node of that compute cluster will do a separate prediction. So it's like you're sharing the responsibility of prediction over multiple nodes of a cluster, and they do the job in parallel, and then they merge the final predictions after. So you're saving a lot of time, and you have the scalability here. You're not worried about choosing the right size at the beginning. You can scale it automatically. And then that triggering mechanism, you don't need to manually go once a week and trigger this. And once a week is just an example. I mean, any schedule you want. You can trigger it based on a schedule, or anytime you want it. You can call this through an API call that we can give it a try. So that's the definition of batch endpoint, and what gonna be the benefit of Azure ML batch point, which is managed here, that we can leverage. So let's start to see what do we need for creating a batch endpoint? What are the requirements here? So in order to do so, there is a GitHub repository that we're going to execute the samples there. So I'm gonna add the link of that to the video description. Let me actually open it shortly. There you go. This is the GitHub repository. I'll again add the link of that in the video description. So if you go to Azure examples and then CLI, you should be able to see the endpoints. You can see we have batch, real-time or online. This time we're gonna deal with batch. And there you go. There are some examples that we can give it a try. Let's say the MNIST, the famous data set. We're gonna create an image-based model that can do the prediction, detect the digits with the given input image. Regardless of the model and the use case, this is just an example to show you the concept and how you can scale it for your own solution. Awesome. So the critical question is, what are the components, MG, that I need to have in place to create a batch endpoint? What are the artifacts? What are the files? What are the codes needed, specifically here when we talk about batch endpoint in Azure ML, to create a solution there? So there are 4 things that you need to have in place, and they're actually here for this example. So we have an actual example that I'll show you. The first one, and very obvious, you need a model. You want to deploy this model in a batch endpoint, right? So your model can be like a file here. I think it should be in this folder. There you go. For example, for this example, the models are trained. We can see it's a pickle file, serialized file here. We can just leverage it. Or your model can be already registered in Azure ML. If you know Azure ML, we talked about a lot about Azure ML in all the videos. You know that you can register your models in model registry of Azure ML, so you can refer to that registered model in Azure ML. Or here as an example, after I have the model out of Azure ML in a separate file, that's okay. We can even refer the model as a file here in this directory when we're deploying. So again, what was the first thing? Model, you need to have it. The second thing is code, or a scoring code. What is a scoring code? A scoring code is the way that you will tell to this endpoint how you are going to load your model and do the prediction. Obviously, it's a Python code that it will load the model, get the input data in a function, call your loaded model in memory, do the prediction, and save it somewhere. So I explained it in a very simple manner, but if you code, you have to make sure you precisely follow all these steps. Let me show you an example that we're going to use. So we have the model for this example to leverage it. The second thing is code. Let's check out what is this code. Yes, this is the scoring code. So digit identification, that's the model that I showed you. It is here. And now it is the code that shows how to load that model in init function and how to use that loaded model in run function. So for any scoring code in Azure ML, you have to have these two functions, init and run. So in init function, I'm loading the model and put it global because I want to have this loaded model in this function accessible inside the second function. You can see that it's actually importing TensorFlow here. The model is already trained, so I'm getting the model with the given input path, and then I leverage this loaded model inside my run function, and the input of my run function is the mini batch. Okay, this is very important here. Remember I told you that in batch endpoint, you can have your input data in multiple batch sizes over multiple nodes of a compute to do the prediction in parallel. For example, if you have 100 images and you have 10 nodes in a cluster, you will have the batch sizes of 10, 10, 10, 10 images, and each 10 bucket will go to a separate node of a cluster. So that's why here we call it mini batch, because that mini batch will be a portion of your input data, go to a node of a cluster and do the prediction in parallel with other nodes, which they do the prediction over different inputs. So with having that in place, and for each image in the input data coming in, let's say 10 images are coming into this node, I'm opening them and I do the inferencing with the given model. I have the results back appended, and I return it as a list. Let's say the detected digit from that given image. That's a, let's say, handwritten image. Someone has written number 2, and your model should be able to digitalize it and say that this is detected as number 2 from the given image. So we have the model, we have the scoring file. What is the third thing that we need to have? Well, of course, when you execute your solution over a compute cluster, your model needs some packages, libraries, let's say scikit-learn, TensorFlow, here we saw that. So these should be installed in that compute, right? So the way that we define what packages are needed in this compute is called environment. And that environment can be defined through a Docker image plus some conda packages dependencies. So we need a Docker image here with conda dependencies here. For Docker images, we can refer to Microsoft images. So Microsoft has created some curated environment and images that has the well-known data science packages in that image. It's maintained by Microsoft. So in order to, instead of coming up their own image, we can just call them or create our own custom image. For this example, if I'm not mistaken, we're gonna use a curated image, but we're gonna come to this shortly. So let's check out what are the conda packages we are defining to tell the solution and endpoint that, hey, these are the packages we need to have them installed. Let me go back to MNIST. There you go. There's a folder called environment. And you can see there's a YAML file called conda YAML that describe the dependencies that we need to install on the top of a Docker image that we're going to choose for this badge endpoint. Perfect. We have the model, we have the scoring code, and now we have the environment defined with conda packages. The last thing that we need, obviously, is the compute. So you have to also tell to batch endpoint that, hey, I want to have a compute, but what type of compute? CPU, GPU, how many nodes, how many, let's say, amounts of memory, number of cores you want to have on each node of cluster. So you have to specify that. Awesome. So we know what we need to have in batch endpoint, and we know that we have them all in this example. Then let's use these files and let's see how we can create this. For creating this batch endpoint, we can use Azure ML UI. It's very simple, but here to make it a little bit different, this time, because in real-time endpoint I talked about the UI, this time I'm gonna use the CLI in Azure with Azure ML extension and V2 version 2, so we can see how easily we can actually create an batch endpoint using CLI. So let me open up my environment to run CLI code. Here I'm just simply using PowerShell to run my AZ commands. So the first thing that you need to do if you want to execute this CLI code, you have to of course log into your Azure. So if I hit AZ login, I already did, it will pop up a window browser. and you have to put your credentials to get authenticated, and when you're logged in, you can now start to interact with your Azure subscription and the Azure machine learning workspace that you have. So because we're going to do some ML stuff with CLI to connect to our Azure ML workspace, not only you have to have CLI install, Azure CLI installed in your machine, but also you have to install the ML extension of Azure CLI as well. How you can do it, I already done this, but just want to show you quickly. Here it is. So when you have Azure CLI installed, you can check out the version. It's best practice to actually upgrade it. So you can just type AZ upgrade, because for creating the machine learning extension of CLI, you need to have your Azure CLI more than 2.15. And then making sure you have the right version, you can just add AZ extension add ML. That's it. Remove the previous ones to make sure you install the latest one, and that's it. You're good to go. So coming back to my PowerShell, what's gonna be the next code that we need to execute? So I ran all the codes before I record the video, so I'm not going to execute them again. That's gonna take time, but just want to show you the flow how I did them. So the next thing is, when you log into to Azure using Azure CLI, you have to say that which subscription of your Azure you want to interact with through CLI, because you might have multiple subscription, right? So you have to tell Azure which subscription and which Azure ML I want to deal with using the CLI here. So just copy and paste your subscription ID, and this is confidential, so put it safe. Just paste it here, and then you're good to go. You're set with that given subscription. Now you have to tell also, okay, hey Azure CLI, this is the subscription that I'm going to work with, and this is the Azure ML workspace that I'm going to deploy this batch endpoint. This is the way that you can now define which Azure ML workspace you want to connect to and work with. So let me paste the code here. There you go. You can see that, hey, I am saying that by default I want access to this workspace, so you have to change this part with your workspace name. For example, mine is MG, which is inside this resource group name, so change it with your resource group. And this is inside this location, let's say East US, so change it with your location. That's it. And I add the link of the website and documentation that have all these codes step by step, so you won't miss anything. Now I'm connected to the Azure ML. The first thing that I need to do, because I want to use these examples that I just showed you here, so I have to clone them to my machine, because I want to deploy this model with this environment, with this scoring code as a batch endpoint. So very simple, if you have to git install on your machine, here in the PowerShell, what I can do, just simply, let me delete this part, I have already executed them. You can just say git clone, GitHub Azure ML examples. This is exactly what I'm cloning here. And then what you need to do, you have to go to the folder that has this batch endpoint example. So what you can say, you say that I have cloned this. Actually, I can clone it right now. Let's do it. I can do it again. Oh, it's already exists. Okay, let me try to delete and clone it again so you can see it in action. All right, there you go. It's gonna take a bit of time. Maybe I didn't need to clone everything, but that's fine. So let me pause recording, and when it's done, I will come back. All right, it's done finally. And now I want to navigate to the CLI folder because I have cloned this repository. So it's simply saying, let me actually copy that. It's faster. Just using CD, I want to navigate to this directory, Azure ML example CLI, which is here. And if I do a quick ls to see the list of files in this directory, you can see the batch endpoints and all the components that we have here are inside this CLI folder. I can see it accessible in my machine. Now, what I want to do, because I have these artifacts on my machine, and I have CLI, I can now deploy this batch endpoint with all the assets that I need, not all of them, the one that we talked about, over Azure ML Workspace, because I'm connected to Azure ML Workspace with the code that I showed you using CLI. But before, again, we needed 4 things for deploying batch endpoint, and one of them was compute cluster. So let's create that. How you can do it? You can use UI, you can use Python SDK, but because you're using CLI, so let's use CLI also to create a compute cluster. And this is, let me actually try to paste, copy the code. And this is the command line that you can actually use with Azure ML CLI to create a compute cluster. You say that, hey, Azure ML CLI ML, create a compute for me. Give it a name. Here I call it batch cluster, MG cluster, whatever. And that's going to be an ML compute type with 0 to maximum 5 instance or nodes. Quick question, what does that mean, 0 nodes? I mean, you're meaning that I'm creating a cluster with 0 nodes? That means nothing gonna be exist. That's correct. When I hit this command line, it's gonna create a cluster, but I will charge for nothing because it will have 0 nodes, so I'm paying for nothing. But when I started to do batch prediction, it will gradually start to scale to launch one node. Oh, the workload is heavy, let's launch the second node. If it's needed, let's launch the third node. So as much as you need to maximum 5 node, because I'm telling this is the max 5 node, it will launch the cluster nodes, do the prediction in parallel, and when the batch endpoint job is over, it will shut all of them now to the minimum number, which is 0. That means you just pay for the time that you do the batch prediction, and when your prediction is over, you're paying for nothing. This is great. So you don't need to have a server running 24/7. Just pay for the time that you're doing the prediction and it will be shut it down by itself automatically. So no worry about forgetting to shut down the cluster. This is fantastic. Alright, I created already, so I'm gonna delete that. Now we can start to create our endpoint. So for creating your endpoint, of course, you need to give it a name. Okay, so with very simple CLI command line here, let me paste it. Okay, let me copy that again. There you go. I say that Azure ML CLI create a batch endpoint with the given name. Let's say, I don't know, MG endpoint or whatever. Okay. Again, I already did this, so I'm gonna delete that part. And now when you have that endpoint created, you have to say that, hey, this is the endpoint you created with the name MG. Now I'm gonna give you the model, the environment, and a scoring code that you need to create my batch endpoint. This is actually the main part that does the job for you. So I ran this actually yesterday, but to show you how I did, here's the solution. Hey Azure ML CLI, create a batch deployment for me and give it a name. Non-ML flow, it's the example coming from. You can say that MG or whatever you want to create, that's the name of your batch deployment. Over what endpoint? The endpoint that I just created before running this command line, which was again MG, for instance. So you already have an endpoint created, but now you're deploying your solution over the MG endpoint you created. And you say that this is the file, the YAML file that explain how I would like to deploy this. Where is the code? Where is this coding file? So you don't need to specify the one by one. You just refer all of them in the YAML file, and that YAML file will have all those information needed. So you need just one YAML file to create an endpoint. Done. When I hit enter, it created the endpoint for me. But okay, we understand this command line, but what is this YAML file? This is the main part. It seems that this is the only thing needed for creating this endpoint, but so it should include everything. Let's check that out, okay? So I go to the batch folder, non-ML flow deployment here. So batch, let me check where that is. There you go, non-ML flow deployment. Awesome. You can see that in this YAML file, I am telling to the batch endpoint that, hey, this is the schema of this YAML file. This is the name of my deployment. This is the, for example, MG endpoint name that I want to deploy this. Where is the model? Well, the model is here. The current directory, MNIST model. We checked that, right? It's here. Where is your scoring code and all the codes needed for this deployment? They're specified here in this directory. What is the environment? Remember I told you we need a Docker image. It's using Microsoft image. I'm just giving the name of that. With the conda dependencies, the packages I showed you, which are in this current working directory with the given path. You need, of course, a compute, a resource, right? because I already created the compute before, I can just refer that. I say that, hey, Azure ML, I already created a cluster. I called it batch cluster. So use that one for executing the batch endpoint. And then I'm saying that when you're doing the prediction by each node, well, each node will have the prediction separately, right? So by the end of the day, you need to merge all those predictions coming from different nodes. That's why I'm saying that append all those predictions and give me just one file in the CSV that has all the predictions merged by the outputs of each node of the cluster. And some optional specification, you can say that the maximum retries you can have, the maximum timeout, error threshold. You can say that, hey, batch endpoint, if this batch endpoint or the model fail to, let's say, predict 3 images sequentially, stop the process. Or here with -1 means that I don't care how many errors gonna happen. Go ahead as much as you can predict and just skip the ones you cannot do any prediction. So this YAML file magically will specify all the components we need to have. So when you want to deploy this batch endpoint, you can just refer to this YAML file. But of course, for creating this YAML file, you need to have these components in place: model, scoring code, environment, and compute. So when I ran this, let me show you what happened in Azure Machine Learning Workspace. There you go. This is my Azure ML Workspace, which you must be familiar with so far. And you can see that in my endpoints, batch endpoints, I have an endpoint called MG that has been created. And you can see the specified information about my batch endpoint, the model ID, what compute that I used, what environment being used, exactly the stuff that we specified are registered here, created for me, and ready to be used. The very critical thing here is that, okay, I have an endpoint deployed, but what does that sign mean? Add deployment. That means adding a deployment on the top of deployment? Yes, you know what? Let me come back to this picture. When you have a batch endpoint created, you might update this batch endpoint with new models, right? So you can use the same endpoint but deploy multiple models as new version of your solution. That's why one of them will default, the one that you use in production, and when you have a new one, you deploy it, and then you say Azure ML, hey, change the default from the first one to the second one, because that's the new model for this batch endpoint. That's why here you can say that I want to add a new model over the top of this batch endpoint and make the second one as a default deployment. So you change it here. And if you want to use this endpoint, just create a job out of it. So let's create a job using again a CLI to do the actual prediction and see how my input images will be in multiple batch sizes, go to my cluster, and the final results will be appended in a single file. Opening my PowerShell again. So let me remove this part. There you go. So I changed the code, and here's how I can trigger this endpoint to do the prediction for me. So I'm saying that, hey, Azure ML CLI, I want to trigger or invoke a batch endpoint, and the name is MG endpoint. I can change it to my, or MG batch actually, sorry, this is the name I chose when I was executing the code. So MG batch should be replaced by this green line. And my input data, which I want to do the prediction, and this is the input going to the model. The input data can be a data set stored over cloud. For example, here the data is stored, it's open data set, like, right? MNIST is a famous data set, which is over a public data set over a blob. So I just have the URL, I'm good to go. Or it can be a registered data set in Azure ML in here. And you know that you can register a data in Azure ML and give it a name. For example, MG data 01. So if you have that data registered with this name, you just give the name of that to this code instead of this URL. So Azure ML will know where is the input data to do the prediction. Or if your file or data set is on-prem, the machine that I'm, for example, executing the CLI, you can use your directory of the images and input data that you have on your machine. So those files will be uploaded automatically to Azure ML to go to your input model to do the prediction. And that's it. So I executed that. What happened? I created a job with triggering this Azure ML batch endpoint. So let's see the job results and what happened. So if I go to jobs, You can see that there's an experiment with the given name. Actually, let me see. Yeah, there you go. That's the last one and first one I created. And you can see there's a nice chart automatically created that says that, hey MG, you created a job using a batch endpoint. Your data was coming from a URL and went to your batch scoring model. And we can see that it successfully got created. And of course, I have the solution, the final outcome, predicted values in a single CSV file. So where does it go? What are the predictions? By default, Azure ML will create a folder in default blob storage of Azure ML, which is attached to Azure ML, and use the job ID, this job ID, as the name of that folder, and your prediction is gonna be inside that folder. Let me show you mine. There you go. This is my default blob storage. Let me check if that was the correct job ID. Scoring. There you go. Predictions.csv. That's how I specified it. And if I click on edit, you'll see that each input image that I gave to the batch endpoint were converted to mini batch images, and the events all go to different nodes, and each node predicted, for example, the first handwritten digit is 1, predicted as 1, predicted as 9, so it is 0 to 9 digits. And then the results got all merged to one single CSV file. And let's check how many images I had. So 1000 images. I was able to do the prediction. Let's check how long it took actually. I didn't check by myself. I'm curious to know. Let's see the job overview. Duration 7 minutes. So in 7 minutes I was able to do the inferencing for on 1000 images, but of course you can scale it further with more powerful machines, more number of nodes, and specify better type of batch sizes. You can tell to Azure ML what gonna be the number of batch sizes for each node, so you will use the most out of each node when you do the batch prediction. So that's all. So this is a great capability that you can have your batch prediction as an endpoint, and then you can schedule these endpoints or trigger like an API call whenever you want to do inferencing in a batch scenario. Hope you enjoyed. Once I asked life, why you're so difficult? Life smiled and said, people won't appreciate easy things. Take a good care, my friends, and we'll see you shortly next week.